Question number 16 of the IT Passport exam from PhilNITS. In this question, we are being asked, which of the following is a representation of the relation between the failure rate and time? First, we need to know what exactly are the inputs. For example, we have here something about failures and them being into 3 periods. Them being put into 3 periods, and the first one being the initial failure period, where you got the random fail, and then you got the random failure and the wear out failure. For the first initial failure, we have here decreases, the rate of failure decreases, and then the second one is a much more stable state, and the failure rate is effectively constant, and it's random. It doesn't increase, doesn't decrease, it's pretty much in a stable state. And then finally, we have the wear out failure period that we can see the failure rate increasing as time goes by. So given these inputs, what can we say about the representation of the relationship between the failure rate and the time? I think I remember answering this question, and I answered letter B, which turned out to be incorrect, because according to the answers sheet, the correct answer is the letter C, which is the bathtub curve. And I think we need to know why. First, let's look at the other choices. For example, the Gantt chart. Gantt chart, we know, is used with project management. For example, you want to know how many man hours you need to put in to finish a particular work task. And then after putting them all in a chart, like a chart that you can do using Microsoft Excel or any of the spreadsheets out there, like the LibreOffice calculator spreadsheet. You put them in a spreadsheet, and we can see how long it will take overall to finish all these tasks. And you can of course put them in a parallel type of chart, but at the end we need to know, after you've done all the tasks, how long will it take, how many man hours, because from the man hours we can compute how much we'll need to pay. So that's the Gantt chart, and it's not quite like what the inputs are asking for, so we cross this out. For the other one, the radar chart, I think this can be used if you have a graph and you need to know, for example, something that I remember with the radar chart as an example is the one about the stats. For example, in one of those Nintendo DS games, like the Brain Age game, if you continuously practice with the math related mini games, then your math skills would of course improve. But if you forget the other skill sets, then that part won't increase. So you will be stuck with a sort of a strong mathematical skill set, but um, the chart won't give you won't show you that the other skill sets are also I mean, the chart will show you that only the mathematical skills are increasing, and if you have like a graph like this, and we're plotting these points here, like say for this one, this is your math skill and the other skills are only like this, because you haven't been training yourself too much. Then if you create the radar chart, it will be kind of like going in this kind of way, right? Okay, so in this case, we're not really going to be able to use the radar chart, so we cross this out. And so we're left with letter B or letter C. And I answered letter B because I thought that bathtub curve was kind of like a joke choice. But the reason why I chose this also is because it looks like it's about reliability. If you have a lot of failures, then it doesn't seem to be reliable. And then, of course, eventually, I learned that because we're also talking about growth, then it should be going up, right? If you're growing, then it should be going up. But if you look at the inputs, it says here that um, it's going down, the number of failures, and then it goes into sort of like a stable state, like a plateau, and then it increases again. So in that way, it looks like it's not all growing, it's decreasing, and then arriving at this stable state and then growing. At least the count of the failures. So turns out this one is not correct, and we have to go with letter C, the bathtub curve. Now, if we look at my notes, maybe we can find something more. So just like what I drew a while ago, failure, and then the time for the x-axis and the failure for the y-axis, and we see this curve which looks like a bathtub. That's why it's called the bathtub curve. If we go down some more, we have here some of my additional notes. Let me make this much smaller a little bit. So we go first with the initial, and then the part where you have a random set of failures, which not too much. That's why we hit this plateau. And then when the I think it's a device that or the system fails, uh, increases its failure rate, then it's because it's wearing out. So that's why you have this. Okay. Um, and then for reliability growth curve, we have to focus on this word growth, which means it's supposed to improve. But this one is saying that the failure increases. So this is definitely not the correct answer because this one is supposed to be increasing in terms of failure. Okay? So in the end, what is the correct answer? The correct answer is letter C, the bathtub curve.